Good morning, everybody, and happy Friday to you. How are you doing today? Are you ready to do some super maths? I do hope so. Let's see what we're going to need for today's lesson. We don't need a lot today. We just need a whiteboard and pen and a pencil and paper, or a pencil and our book. And now, I'm sure you've got those things to hand already, but if you need to go and get them, pause the video, run and get them, and then we'll be ready to start. Okay, let's get our maths brains warmed up. I've got 3 challenges for you to choose from today. And in all of these challenges, you've got to work out what number is represented by the shapes. And let's look at the first challenge, the green one. All of those shapes there could be either the number 1, 2, 3, or 4. All of the circles would be the same number. All of the triangles would be the same number. All of the squares would be the same number, and all of the stars. So you've got to use something called trial and error. That means just trying different things out. So you could try putting a 1 into the circles and seeing what that does, or a 2, or 3, or a 4. And you've just got to see if you can make all of the calculations work out. You might want to try the middle yellow challenge. And if you try that one, well, I haven't given you a choice of numbers. It could be any number that you use, but I have given you some of the answers. So we can see that circle add square equals 8. So you've got to use, again, trial and error to see if you can work out what numbers go in all of those shapes. And then on to our final challenge, the submarine challenge. I've been a little bit mean on this one because I haven't given you any numbers. So I bet you're thinking, how can we do that? There's no numbers there to get us going. Well, you've got to use your knowledge of calculations. I'll give you a clue. Think about what you know about multiplication, looking at the very first calculation. Circle times circle equals circle. That is the key to unlocking the rest of the challenge. So choose which one you're going to do. I'm not going to give you a timer for this one. I'm just going to ask you to pause the video and come back once you've done it. Okay, good luck, everybody. Okay, how did you get on with that one? Well, let's see if we can find the answers. Okay, let's start on our green challenge. So we know we can only use the numbers 1, 2, 3, or 4. Well, let's use that trial and error. What happens if I put the number 1 in the circle? So 1 in that circle. If I put 1 in there, all of the other circles have got to have 1 in them. So 1 add 1 equals 2. And that means if the triangle is 2, I can fill in the other triangles. And that means 1 add 2 would be 3. If I know that square is 3, then that square's got to be 3. 2 add 2, that would be 4. And we'll see if this works out now, because 1 add 3, yes, that equals 4. So that is the solution to the first one. On to our middle yellow challenge. We've got circle add square equals 8. So using my number bonds to 8, I could either put in there 0 add 8, or I could put 1 add 7, or 2 add 6, or 5 add 3. So the solution to this one, if the circle is 3, all of the circles have got to be 3. There's only 2 of them. And if that's 3, the square's got to be 5. 3 add 5 equals 8. And that means the other square's got to be 5. On to the next one. 3 add something is 10. 3 add 7 is 10. And that means that triangle down there has also got to be 10. 5 times something equals 10. Well, I can use my knowledge of my 5 times table, and I know that 2 lots of 5 is 10. So 5 times 2 is 10. And if that star is 2, that one's got to be 2. Something divided by 2 is 7. Well, we know from our work on multiplication and division that division is the inverse of multiplication. So I can use my 2 times tables facts. 2 times 7 is 14. So 14 divided by 2 is 7. And on to our final challenge, our going deeper challenge. Circle times circle equals circle. That was the key to unlocking this. The only possible numbers that could go in there would either be 0 or 1, because 0 times 0 equals 0. If you've got nothing and you multiply it by nothing, you've still got nothing. If you've got one apple, and you multiply it by 1, you've still only got 1. So the only numbers that could be was either 0 or 1. If we put 1 in that circle, that's got to be 1, and that's got to be 1. And then all the other circles have got to be 1. So 1 add 1 is 2. All of the other squares have got to be 2. 2 times 1, yep, that equals 2. 2 divided by 2, yep, that equals 1. Then we've got triangle, add 1 equals 1. Okay, what are we going to add on to 1? to leave us with 1. You add nothing on, 0. So those are the solutions. Well done if you managed to sort them out. Now, I hope that's got your maths brain warmed up and it hasn't burnt it out already. I hope not, because we've got lots of maths still to do. And in today's lesson, we are going to be adding together 3 lots of numbers, 3 one-digit numbers. And first of all, we've got our friends Poppy and Walt joining us today. So good morning to Poppy and Walt. And they've got a whole load of counters there to sort out. They've got to work out how many counters they've got. You go first then, Poppy. How are you going to sort those out? Oh, Poppy has spotted that she has got 6 blue counters and she's got 4 red counters. She's put them in her tens frame. And then she has got 2 more yellow counters. So she used her first tens frame. She filled it up with 6 and 4 to make 10. And then she added on 2. Altogether, she's got 12 counters. Oh, good work, Poppy. I like that. What about you, Walt? What are you going to do? Oh, he's spotted that he's got 4 red counters. And he's got 2 yellow counters. I wonder what he's thinking. Oh, look, I know what he's thinking. He's spotted that 4 and 2 is 6. How many blue counters has he got? He's got 6 blue counters as well. So 4 and 2 makes 6, and he's got 6 blue counters. He's made 6 add 6. He's found double 6, and altogether he's got 12 as well. Oh, you both have got 2 very clever ways to add together those counters, haven't you? Poppy is saying she likes finding 10. Well, that worked out really well for you today, didn't it? And Walter's saying he likes finding doubles, and that worked out well for you as well. I tell you what, you two, I'm going to give you some calculations. There we go. I've even given you the answers. And the children who are watching, what you've got to do, children, is see if you can look at those calculations and see if you can use Poppy's way of finding 10, or see if you can use Walt's way of finding doubles to work out the answers, to get to the answers. Okay, pause the video whilst you have a little think about that. Okay, let's have a little look. So we'll start with Poppy's way. She likes to find 10. So in the first calculation, we've got 4 add 2 add 6. Can you make 10 out of any of those numbers? Oh, look, I know what we can do. 4 and 6 makes 10, and then we can do 10 add 2 is 12. What about the next one? 7 add 3 add 4. Can you make 10 out of 7 and 3 and 4? Yes, you can. 7 and 3 makes 10. 10 add 4 is 14. What about the next one? There's Walt. Can Walt make any doubles there? 4 and 2 makes 6, and then he can do double 6, which is 12. What about the next one? 7 and 3 add 4. Oh, that's tricky, isn't it? Oh, I think I've spotted it. 3 add 4 is 7, and then we've got double 7, which makes 14. Oh, good work, everybody. I'll tell you what we can do. Let's have a look at these calculations and see if we can use Poppy's way of finding 10 or Walt's way of finding doubles to solve these calculations. So what I would like you to do is to pause the video, look at each calculation. You might be able to use finding 10, you might be able to use finding doubles, you might be able to use both of them to solve the calculations. Pause the video, should take you about 5 minutes or so to have a go at these, and then we'll go through the answers in a little bit. Okay, how did you get on? Let's go through each calculation. So question A, 7 add 3 add 5. Can you make 10? Yes, you can. 7 add 3 makes 10 and 5 is 15. I can't see any doubles in that one though. Question B, can you make 10? Yes, 9 and 1 makes 10 and then 10 add 8 is 18. Can you see any doubles in there? Look, 8 add 1 is 9 and then 9 add 9 is 18. Question C. Okay, Poppy's way. Can you find 10? Yeah, look at that. 6 and 4 is 10, and then 10 add 6 is 16. Can you use Walt's way of finding doubles? Look at that. Double 6 is 12. 12 add 4 is 16. Okay, question D. Can you make 10? Yes, 3 add 7 is 10. 10 add 9 is 19. Can't see any doubles in there though. What about E? Well, that's 5, add 5, add 5. We're quite good at counting in fives, aren't we? We could just go 5, 10, 15, or we could use Poppy's way of going 5 add 5 is 10, and 10 add 5 is 15, or we could use Walt's way of saying double 5 is 10, and 5 is 15. Then question F, 2 add 9 add 8. Can you see any doubles in there? Can you find 10? Oh, look, 2 add 8 is 10, 10 add 9 is 19. Good work, everybody. I tell you what, Poppy and Walt, I really like your ways, your clever strategies of finding 10 and finding doubles to work out the answers to these calculations. Now, I'm going to challenge you both now. I'm going to give you some more calculations. 7 add 4 add 2. Can you both use your strategies to find the answer? Poppy, can you find 10? And Walt, can you find doubles? Oh, look, Poppy is trying to make 10 with 7 and 4. Poppy, can you show me that on a tens frame? Oh, look, 7 and 4 makes 11. Doesn't make 10, does it? Good try, Poppy. Try something else. Oh, look, 7 add 2. Show me that on a tens frame, Poppy. 7 add 2. No, that makes 9. Oh, so that didn't work at making 10, did it? No. Okay, over to you, Walt. Do you think that you can find doubles? Oh, look, he's got 7 add 4 add 2. Ah, he's going to try and do 4 add 2. No, 4 add 2 makes 6. And then you've got 7. So that's not going to work either. Oh, bad luck, chaps. Well, that is a shame, isn't it? Oh, Poppy's saying something. Oh, Poppy's got an idea. What's that, Poppy? Oh, she thinks because she couldn't find 10, she can use partitioning to make 10. What are you going to do, Poppy? Oh, look, she split the 4, partitioned the 4 into 3 and 1. Can you see how she's going to make 10? Look what she's going to do. The 7 and the 3 make 10. And then she's got the 1 and the 2 that makes 3. So she can then do 10, add 3, which equals 13. That was a clever thing to do, Poppy. Well done. What about you, Walt? Do you think that you can use any clever trickery to find doubles? Oh, look, he's going to look at that 7. I wonder what he's going to partition 7 into. Ah, into 1 and 6. Why has he done that, children? Oh, any ideas? What's he going to do next? Oh, look, 4 and 2 makes 6. He's going to double it with the other 6, isn't he? So he can do double 6 and then add on the 1 to make 13. Clever work. What? That was fantastic. Well done. Right, let's have a little look in a bit more detail about what Poppy did. So she did 7 add 4 add 2, and she used her clever finding 10 method to do 10 add 3. So let's see how she do that with her counters. So there's her 7 yellow counters, 4 red and 2 blue ones. Okay, show us that on a tens frame, Poppy. There's the 7 yellow counters, and there's 4 red counters, and 2 blue counters. Now, how is she going to move these around to make 10? She's going to partition the 4 red counters into 3 and 1. There goes the 3 over there. Ah, she's made 10 over there. And then she's got 1 and 2 left over the other side. And that is where she got the 10 and the 3 from. Good work, Poppy. I wonder, children, do you think you can have a go at using Poppy's method to solve these calculations? So in all of these, you've got to make 10. In question A, you can see the number bonds to 10. In question B, you can see the number bonds to 10. But in C and D, you can't. You've got to use that clever way of partitioning to make the number bonds to 10. Pause the video here, have a go at those calculations, and come back in a few minutes once you've done them, and we'll go through the answers. Okay, how did you get on? We'll go through the answers together. So if you didn't manage to get them, we'll go through them now. Okay, 9 and 1, that makes 10. That's our number bonds to 10, and then 10 add 4 is 14. Question B, where can we make 10? Oh, look, 8 and 2 makes 10. So 10 and 7 is 17. Question C. I can't see a way of making 10 there. We're going to have to partition, aren't we? We're going to have to partition 3. And if we partition 3 into 2 and 1, that means we can make 10 with the 8 and the 2. And then the other numbers, the 1 and the 1, make 2. So we've got 10 add 2, which equals 12. And then 3 add 6 add 5. Well, we could partition the 6 into a 1 and a 5. And that means we can make 10 with the 2 5s. And then add the 3 and the 1 together to make 4. So we've got 4 add 10 equals 14. Now, it's time for you to have a go at some challenges yourselves. 3 challenges. We've got our green, our amber, and our pink challenge. So let's look at the green challenge. You can solve all of those ones by looking for the number bonds. So in those sets of 3 numbers, there will be 2 numbers that add together to make 10. So look for those to solve the calculations. In the middle challenge, you may be able to find the number bonds, but most of those questions, you are going to have to partition one of the numbers to make 10. Okay. And on to the final challenge. Well, you've got a few things to do here because you have got to solve both sides of those equations, and you can use either your doubling or your number bonds method of making 10 to find the answers. And then you've got to put in the more than, the less than, or the equal sign to show which equation is greater or less, or if they're equal. Okay, pause the video here. Hopefully 10 minutes should be enough, but take as much time as you need and then come back when you are ready to go through the answers. Good luck, everybody. Okay, on with our green challenge. Let's look at the answers. So we have got 6 add 4 add 5. 6 and 4 are the number bonds to 10. So 10 and 5 is 15. 2 add 8 make 10. 10 add 3 is 13. 7 add 3 makes 10, and then 10 add 5 is 15. 5 add 5 is 10, 10 add 6 is 16. 9 add 1 is 10, 10 add 8 is 18. 4 add 6 is 10, and 10 add 5 is 15. Well done if you got them right. If you had any wrong, just have a little go at them again. On to the next challenge. Okay, question A. Oh, look, 5 add 5 makes 10, and 10 add 4 makes 14. Question B, no, I can't see a way of making 10 there, so I'm going to have to partition. I can partition 3 into 2 and 1, and then I can make 10. 10 add 6 is 16. On to the next one, I've partitioned the 5 into 3 and 2, so 3 and 7 make 10, 6 and 2 is 8, 10 and 8 is 18. And then on to the next one. I've partitioned 5 into 4 and 1, so I can make 10 out of 6 and 4, and then the 7 and 1 makes 8. 10 add 8 is 18. And then the next one, 6 add 8 add 3, I've partitioned 8 into 4 and 4, so 6 and 4 is 10, 4 add 3 is 7, 10 add 7 is 18, and last of all, 9 add 3 add 8, I've partitioned the 3, and oh look, we can make 10 twice. 9 add 1 is 10, 8 add 2 is 10, and 10 add 10 is 20. On to the last one. So here are the answers. So hopefully you've managed to use your strategies to find the answers. So the answer to question A, the first one is 15 and the other side is 15. So those two equations equal, they balance, don't they? Question B, the side on the left is 17 and the side on the right is 15. So 17 is greater than 15. And then question C, 1 add 7 add 5 makes 13, and 3 add 4 add 5 makes 12. So 13 is greater than 12. And the last one, 8 add 9 add 1. Well, 9 add 1 is 10. Add on the 8 is 18. And on the other side, we've got the same numbers, just in a different order. 1 add 8 add 9 is 18. And both sides balance. They are equal. Well done if you got those ones correct. And that brings us to the end of today's maths lesson. We've been looking at how brilliant mathematicians add 3 one-digit numbers together. And we've been finding out that we could use doubling, or we could use making 10 or finding 10 to find the answers to those questions. That's it for today. That's it for this week. So I look forward to seeing you next week, where we will do some more super maths, and we are going to be doing some subtraction next week. So have a lovely weekend. I will see you next week. Bye-bye.